So how much would you pay to run a frontier AI model continuously working for you for an entire hour? Well, with Claude Opus, you're looking at somewhere between $15 to $20 per hour, depending on the throughput. With the GPT-5 models, you're probably looking at something similar to that, and probably even more for the new Spark model that they did with Cerebras. But MiniMax has just launched the M2.5 model, and they're claiming that this costs $1 an hour. So that's based on basically around about 100 tokens per second. And normally I'd be really suspicious of claims like that. Except that in this case, they've actually got some really good third-party evidence that I'm going to go into, which I think shows just how good this model is for real-world software engineering and office tasks. So in this video, I'm going to break down exactly what makes this so interesting, what other people, particularly a very specific organization, is saying about this model. And then we'll also have a look at how this model could actually be sort of a killer model for something like OpenClaw. So let's jump in. So MiniMax is one of the top AI companies in China. And they've basically been plugging away at building better models in all sort of areas. So we've obviously had the LLMs, but we've also had some vision models, and they've also been doing some things around audio models as well. Now, currently, as I'm recording, this model is not open weights yet. We don't know exactly what the license will be if they release an open weights version. Interestingly, though, they have shared the weights with a lot of other companies to actually serve them. So you're not just limited to using MiniMax in China or using servers in China or anything like that. Most of the companies that are actually serving open weights are serving this. And if we look at it, we've even got companies like Olama that's partnered with MiniMax to serve their model with their cloud option for free for the next couple of days or so. So it will be interesting to see if the model actually makes it fully public. But you got to think that MiniMax is actually on a roll here. This is their third iteration of one of the M2 models in the last 108 days. So that's just over 3.5 months. And they've released the M2 model, the M2.1 model, and now the M2.5 model. And interestingly here, the M2.5 model, they've actually released two versions of it on their API with the exact same capability. And the only things being different is the speed and the price. So one of them is operating at around 50 tokens per second. The other one is operating at 100 tokens per second. Now, I don't want to harp on their own benchmarks too much in here, but you can see that the model is definitely competitive with both the Opus 4.5 model and perhaps often even with the Opus 4.6 model. Certainly competitive, if not beating the Gemini 3 Pro models. And again, holding up well against GPT 5.2. They haven't benchmarked GPT 5.3 in here, so we may find that it's actually a bit better there. The thing for me, though, that caught my attention and made me make this video was not their material and their benchmarks. It was this blog post by OpenHands. So I've talked about OpenHands before on the channel, and if you haven't heard me talk about it, this originally was called OpenDevon, and the whole idea was that this was a project that came out of Carnegie Mellon, where they tried to make an open source version of the Devon coding assistant slash agent system there. And the work that has come out of this has been pretty amazing. So not only have they built a coding agent, they've also done a lot of research into what sort of works in harnesses. I've personally seen them give some really good talks, including a talk at ICLR last year, all around the lessons that they've learned with coding harnesses, coding scaffolds, etc. And they've been very bullish from the start on having an open model that could compete with the top proprietary models for the coding use case. So it looks to me that they basically had early access to this, and they've benchmarked this as the top open model. So they're calling this an unlocked model in here. So maybe they know more than we do of actually what's going to happen with the weights to this, etc. But the thing that really blew me away here is look at this price. So the average cost here that they're basically comparing against Opus, and we should point out that they're showing that this is still behind Opus, behind GPT 5.2 codecs. But look at that price. It's well over 90% cheaper, and it's able to work with these really long run times as well. So their blog post goes quite in depth about how this actually compares to the Claude models and how this is just so much cheaper for so many different tasks. So that brings us to this raw pricing. If we look at the 2.5 Lightning model, this is the 100 tokens per second model. We're looking at 30 cents per million tokens in and $2.40 per million tokens out. If we're looking at the slower version of that model, which is probably going to be fine for 95% of everything you do with something like OpenClaw, that's roughly half the amount for output. So it seems for the input, you're perhaps the same, but for your output tokens, you're looking at $1.20 per million tokens out. So like OpenHands mentioned, this is often between a 10th to 1/20th the cost of Opus, Gemini 3 Pro, GPT-5. And this is where the $1 an hour figure actually comes in, that if you're running this continuously at 100 tokens per second, this is probably not going to break the bank anywhere near what Claude Opus and OpenAI's GPT 5.3 and especially the new GPT 5.3 Spark are going to. Now, of course, there's an argument that you can make for very fast tokens. I totally agree with that. And there are certain use cases where you want the tokens as fast as possible, even if that's going to cost you a lot more money. And it is also interesting looking at this, that the Chinese model companies do have a lot slower throughput for their inference when we compare to Google, when we compare to OpenAI, and perhaps a little less so when we compare to Anthropic. And a large amount of that you got to think is probably because they can't access the same GPUs that companies in other countries are able to do. But for me, this whole idea of really cheap tokens opens up a whole bunch of new use cases of where you can have things like always on agents that are just constantly doing stuff where it's not going to cost you a fortune. And that can be for coding things. That can be for things like continuous integration, continuous deployment, but it can also be things like deep search and deep research. So I think as builders, this challenges us to think about, okay, where can we just have these always on agents that are constantly just doing different tasks for us? Now, if we jump in to see how they actually did this model, we don't have a full sort of technical paper that actually may come with this later on, but they do provide some interesting tidbits in their blog posts that we can actually look at. So the first one is this improvement rate. So this is kind of amazing that they're showing basically how their models have improved since sort of June last year right through to now, and that the improvement rate that they're going at is actually much faster than a lot of the other proprietary model companies that are out there like Anthropic, Google, OpenAI, etc. So this should obviously raise a big question that how is it that they're improving at such a rate? How are they getting these models to be better and better and better? And it doesn't look like it's just constantly training on more data or bigger models or things like that. These models from MiniMax are actually not very big models in the grand scheme of things. When we compare them to some of the other proprietary models out there, these are not the huge multi-trillion parameter models. So this brings us to what's the inside secret at all the foundation model companies at the moment. And that is the way that everyone's getting their models to be a lot better is through scaling up reinforcement learning training. And if we look at this part here, they actually make some revealing statements. So first of all, they talk about that this is scaling RL, but then they talk about that most of the tasks and workspaces that we perform in our company have been made into training environments for RL. So that would explain why this model is getting a lot better at things like office work and things like generating docs, spreadsheets, all those sorts of things. And they mention here that to date, there are already hundreds of thousands of such environments. It would be awesome if we actually knew what the environments were and what sort of the variations of the environments were. But that definitely seems to be the secret sauce of a lot of the frontier labs is that they're actually paying lots of startups to make environments for various different RL tasks, etc. Now, they go on to then mention that at the same time, they're doing lots of work in their agentic RL framework, their algorithms, reward signals, and the infrastructure around this. And that brings us to Forge, their agent native RL framework. And this sort of brings about a whole bunch of problems that you see when you're trying to scale up this kind of RL training, is that fundamentally it can just be really, really slow. So if you've got some kind of agent that goes through an environment, perhaps let's say it's playing a game or something like that, or doing a particular task, and perhaps if it gets it right, if you're then doing sort of on policy RL, you straight away want to sort of train that into the model so that the model can update learning on this reward that it's done and gotten right. But you're actually making your environment sit around and do nothing. So you've got this challenge of on policy versus off policy. And you can kind of think about this as if you were learning to cook, right? If you were out there learning to cook, if you were on policy, you would make a dish, you would then taste it, you would then get a series of judges to taste your dish, you would learn from the feedback, and then you would make your next dish. Now, that probably is going to get you really good feedback, but it's going to be slow in that case. If you are off policy, maybe you make 50 versions of the dish, you then give them to judges, you get feedback, but now you've kind of forgotten which parts you were doing in each of the 50 versions there. And probably the mistakes that you were making at the start when you were making those 50 dishes are not the ones that you were making at the end. So you've got this whole sort of game of on policy versus off policy. And this is what they talk about that they've done. Now, they don't go into lots of details about how they've done it, but the key idea here is they've got it so they've got these asynchronous scheduling strategies, meaning that the agents can go through different environments, they can generate, they can train things. The agents can go through these different environments, and they're not limited to just generating one trajectory out and then having to train on it. They can actually collect some of those experiences and then sort of assemble them together to do some training and update the weights there. Now, obviously, they don't want those experiences to become stale. So they're constantly having to balance the sort of gap of how off policy is the system overall. And you've got to imagine that they're not just training sort of one task at a time. They may be doing actually multiple tasks, perhaps in sort of a similar kind of area, but they've got multiple tasks going on. And this is where the tree structured merging strategy comes in. This allows it to basically combine some of these things, put them together, and then do the weight updates and the training of the model. Now, the big takeaway here is that this apparently gets them a 40x training speed up from just doing the simple sort of generate one, train one kind of strategy that would massively limit the number of examples that they would actually be able to train on in here. Now, we don't know how companies like Google, OpenAI, Anthropic, etc., actually solve this kind of problem. This is a real sort of secret sauce kind of thing. If you think back to some of the early strawberry models that came out of OpenAI, the O1, etc., there was a whole paper there called Let's Verify Step by Step, this idea of breaking these things down into steps as they're doing some kind of RL rollout. And even in those papers, they basically talked about that they just had some way of doing verification and doing the rewards to be able to work out what parts to credit when you actually do your weight updates and do training. They never actually told us how that's actually been done. So in the past, we've seen companies like DeepSeek really try and do this with GRPO. Here, MiniMax is using sort of like an alternate to GRPO and PPO, which is this CISPO. And while they don't give a lot of examples for this, it seems that this is sort of key to creating the stability in the mixture of experts model as they scale up this sort of large RL training. So obviously, if they're training on so many of these RL environments that they talk about, hundreds of thousands of different environments that they use internally, this is really where we get these sort of super performance in office skills that they've focused on here. And we've seen the same thing from Anthropic, right? As Anthropic has rolled out Cowork, one of the reasons they've been able to do that is because they've got lots of these RL environments for tasks that would be done in Cowork. Just like most of the models out there have really doubled down on this kind of idea for code and this idea of environments for code to get your model to be much better at generalizing to different kinds of code tasks and treating the sort of building of code like it's a game. So overall, just to finish up, this is definitely an interesting model. Like I said earlier on, for me, some of the really interesting parts of this is just how well OpenHands is recommending this model And for looking at a model that OpenHands is claiming is just a 230 billion parameter MOE with only 10 billion parameters active, this is really quite amazing that it can get such good results from a model which is relatively very small compared to many of the proprietary models out there. So if we're coming in here and looking plans that MiniMax is actually selling, at first when I came in here, I kind of looked at this and thought, gee, okay, that's not that cheap, right? Like I already pay $200 a month for Claude Code, until I realized that this is the cost for the entire year here, not for a monthly. If we actually click on the monthly, we can see that the costs are a lot cheaper compared to the models like Opus, Codex, Gemini Pro, etc. Now the models are already up on OpenRouter, so you can actually try it out. So it looks like there are already multiple providers out here. We can see the difference here between the sort of 50 token per second one at $1.20 and the Lightning one at sort of $2.40 here. And my guess is that over the next few days, we'll see a number of different providers already putting these things up. Just remember to always sort of check out the details here. Actually, it turns out that this MiniMax is a provider that's headquartered in Singapore with data centers in the US. But this gives you a great way that you can actually sort of play around with this. Now, I very deliberately haven't made any videos about OpenClaw because there were just so many security issues around it. I didn't want to contribute to people getting in trouble, etc. But if people are interested, I'm certainly going to be testing this model out with OpenClaw and sort of seeing like, okay, how does this actually compare to some of the proprietary models that are out there? And let me know in the comments if you're interested in that. So overall, this is a very interesting release from MiniMax. It's coming on the back of a number of releases from them. Also, lots of other releases going on this week and perhaps even next week from some of the open weights companies in China who often like to release their models for Chinese New Year. The big one being DeepSeek. So it would be very interesting to see if we see that in the next couple of days. Anyway, as always, let me know in the comments what you think about this. If you try it out, I don't think this is going to match Opus 4.6 in quality for everything. But when you're looking at a price that's under a tenth of the price for the previous one, it's certainly got a place for many builders to actually start using this. All right, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.